My name is Matt Caulfield. I'm a engineer over at Cisco. I run a little team out of the Boston office. We do rapid prototyping and rapid development, focus on customers. And for the past year, we've been focused on edge computing. And so my team and I, we asked to hold this BOF here at KubeCon so we could start really digging in with the community to suss out what are the real use cases around edge computing, and what are the actual possible implementations of a system that could actually support edge computing. So this is going to be a pretty open discussion. I don't really have many slides or anything. I really just want to have a real good back and forth. It doesn't have to be a Q&A. It should be multilateral. Before we get started, if anybody wants to be part of this discussion on an ongoing basis outside of the bounds of today's session, I put together a little Google form that you could fill in. So if you can't read that, that's a lowercase f, uppercase M, 5, uppercase A, uppercase Z, lowercase m. You can go there and just fill in your name and your email. Yes? Yes, this will be uploaded on the site, so you can always check that URL later. But yeah, if you do sign up on that, we're not going to share your information or anything. I just want to use it to keep track of people and maybe put together an email list or Slack channel or something that we can start actually having a continuous discussion on this topic, because I think it's going big places. So with that information, let's get started. So I have a few discussion topics. I'm totally open to keeping this as an open mic type of session. If anybody has anything that they want to cover in particular that's not on the agenda, feel free to throw it in there. But here's what I was thinking. So starting off with what is edge computing? Let's see if we can get onto like a common definition of what that is exactly, and specifically where is the edge of the network, and there might be multiple answers to that, and that's totally fine. Let's talk about real use cases. So if anybody in here has a network that they're considering deploying many thousands of Kubernetes clusters in, or even tens of Kubernetes clusters, that would be really interesting to hear, and specifically not just how you're doing the Kubernetes part, but what are you planning to run on those clusters? That's part of the mystery that's out there right now in terms of edge computing. What is the real use case? Is there a reason to do edge computing, and what is it? And then mythical fantasy use cases. So real world use cases and then fantasy use cases. So there are things out there where people think edge computing might be necessary, but maybe it's a bit of a stretch. Maybe there are use cases that aren't near term in the next 4 or 5 years, but maybe they're real in the next 10 years. So maybe they're a fantasy now, but they're reality in the future. So we can talk about those. Talk about beyond the use cases, what do we think is the architecture? How does Kubernetes fit into it? What other tools? And then specifically, let's dig into the problems with Kubernetes. What can we solve with Kubernetes? And then what do we really need to solve at the application layer or somewhere else or some other tools? Try to figure out what exactly can be done. Okay, so what is edge computing? Anybody want to offer a broad definition on that? So my definition is this. Edge computing is just extending the cloud to the network edge. It's very generic. Anybody want to dispute that? Yes, please. So the question was, why would you want to do that? So I want to get to that in the use cases. Yes.
Let's make it a little broader.
Yes.
I mean, edge computing is more opportunistic.
Okay.
Different class of applications.
Oh. Sorry, just wait for the mic. I'm sorry.
So there are different classes of applications. Some have sort of a hard constraint on the edge for latency reasons.
Right.
But some are more opportunistic.
Yep.
In the sense they're good to be on the edge if there is enough capacity, right? Or they're sometimes better off being in the cloud. That means it's really all about TCO, not really about a hard real-time constraint. So I would almost like to call it more of a distributed cloud or computing effort.
Okay.
I mean, if you may.
Yeah.
I mean, as we walk through the use cases, I'm willing to tend to that direction.
Okay, yeah, so defining edge computing is kind of just another way of saying distributed computing or many clusters, and it could be for any number of reasons. That's a good answer. So where is the edge? So I'll give you my context. I mainly work with service providers. So mobile operators, for example, mobile operators like Cisco announced a big partnership with this company in India called Reliance Jio, and they have 180 million subscribers, and they want to put compute at their cell base stations, right? That's obviously an edge computing use case. They're going to have tens of thousands of these sites, and they want to put general purpose compute out at the bottom of each one. So I see that as a potential for edge. I also see other locations in the service provider network as edge, but what is there besides service provider? Yeah.
Yeah, so sorry, I have to be provocative. Again, why would you want to do that? I mean, you can, of course, and it's cool, and there's going to be lots of companies making money on that, but what's the purpose behind it?
Right. Okay. So yeah, let's try to answer that question then. So why not just run? So I guess the corollary would be like, why not run everything in the public cloud? Is that?
Not necessarily.
Yep.
But just because you can do it, why would you want to do it? Where's the business case? Where's the business use case?
Right. Go ahead. Okay.
There's absolutely tons. I mean, so we had a gentleman here talk about anything latency sensitive. So we had people talk about machine learning in the talk earlier. And I know that this is a hot topic, but anything from you want to do voice recognition, you don't want to be sending that all the way around to your data center in Europe for your customers in Asia. Another example might be you have an app and you need to back up the data somewhere. Maybe the internet connection from, let's say, Vietnam to Europe is absolutely terrible in the middle of the day when everyone's awake. So what you have is you have some edge compute thing. People are backing up there, then in the middle of the night when the network's not uncongested, and then streams all those backups back to your data center. I think there are, and I think latency is one aspect of it, but another one is also lots of people deploy in edge colos for many reasons, be it latency and stuff. And like Kubernetes was designed to help make use of spare resources, I wouldn't be surprised if a lot of these people who deploy to the edge have a lot of spare resources going around, and it'd be really great if you could leverage it for many other things. I mean, I'm saying that that would be an example, a use case. If I was running an app and I can't think of what, and yeah, there were network congestion back to my own data center somewhere, then why wouldn't I store it locally and then upload it when the network's less congested? Because no, but then again, it depends on what your definition of edge is.
Yeah,
because
absolutely.
Because for some people, it's going to be the colo. You know.
And I'm not arguing against the colo. We were talking about the cell tower.
Well, we're talking about what and where. So could be the cell tower. That's.
I was asking about the cell tower. You are.
So are you asking about the
Sorry.
cell tower, sir? Or you're just asking in general? Yep. Yes. Yep. Okay. Right. Yeah. So I do agree. We need to be more specific. And I do also question the cell tower as the location. So let's come back to that. Yes, please.
So we're working in industrial IoT, and in some cases with some customers, when you're manufacturing something that is pharmaceutical, it's something that is very sensitive. There is not a possibility for them, or they don't want to send the data to the cloud. So in that case, we need to do edge computing. So it's a customer requirement in some cases. I mean, you could have like a local data center for doing the compute, but then you're building in the entire cloud infrastructure for one use case. In this case, like we have the IoT with the data collection locally, and then in the normal use case, we send it to the cloud, because that's where the compute and the storage is.
Yeah, so I think that's a really good point, is like, is it just a hybrid cloud? Is it just a small hybrid cloud? And maybe you could define it that way. And maybe edge computing is just like a special case of like multi-cluster. I think there's a lot of overlap there. Maybe the difference is that I think of edge computing as anytime you're deploying one of these clusters outside of a data center. I think of hybrid cloud as being somewhere on the edge in a data center, but maybe that's not everybody's definition. And maybe there's a blurry line of what is hybrid cloud, or what is a data center. Yeah. Sure.
But in our case, it's just moving just the compute part. So
Okay.
It's like one deployment moving that piece only.
Got it. So I guess is it necessary to have a distinction between edge computing and private cloud? Is there a difference?
I was just going to say, in my mind, edge computing implies a bit of being like the first point of contact for an end user. That's their first access into the cloud. And that could mean co-location. It could mean specific advertisements being sent to them based on where they're at, just something like that.
Okay. Okay. Yeah. So edge computing isn't really a well-defined term, I guess. That's what we're getting at here. So I think we know it's not what's in the public cloud. We do know that it could be in a colo facility. It could be at a cell tower or a little bit back from a cell tower, an aggregation point in the network, or a hub, or a POP, depending on what type of telco you're talking to. Or it could be in an enterprise network. It could be on an oil rig, right? Or it could be at a disaster site where you only have like a limited uplink up to the cloud. It's somewhere where, and it's very nebulous and fuzzy definition, I know, but it's an extension of the cloud, outside of the cloud. It's somewhere at the edge. Yes?
I'm thinking about it as a mix of perspectives. You think about computing and you think about location. And when you think about edge computing, you really can't think about any of those alone. You need to combine them. So that overlaps a lot with what you would do with, say, if you were thinking about software-defined networking to switch things back and forth based on location. It's not well defined, and it might not be well defined for a long time because we actually have to look at what is feasible and then extend from that.
Right.
So I don't think we will have a good definition of this for a long time yet.
Okay, yeah, so that's fair. Let's stop trying to, and I know that I started this, but let's try to stop defining edge computing and move on to the use cases. So maybe we can figure it out by recognizing a pattern in the use cases. So I'll give you my use case, and then I want to hear other use cases. But my use case that I'm familiar with is the cell tower one, right? And maybe it's not at a cell tower, but at an aggregation point in a service provider network. And I don't want to make this a service provider or a telco conversation. If there are manufacturing use cases or other use cases, I want to hear those absolutely. My use case is service providers. Cisco, who I work for, they work a lot with the big service providers around the world. We sell them lots of routing equipment. Many of them are starting to think about, well, maybe we're not putting all these functions in a router. Maybe we're putting a lot of these functions into general purpose compute next to our routers on our network. And our routers are everywhere. They're deployed in a wide footprint, close to people's home, by the last mile, a little bit back from the last mile. Doesn't really matter. We want the ability to go and deploy network functions out there that are flexible. And then now that we're going and building out these little micro data centers at the edge, we want the ability to go and deploy things like, I'll give you a few initial examples, video caches. And so that's a very real initial use case. So video caching and then IoT type gateways. So that today is something that actual customers are actually buying. And that's a real use case. But I do want to hear from everybody else. What are the other real use cases for edge besides that? Yes.
My wife works for a rather large hospital system, and they're not quite what I would define as edge computing, but one of the use cases for them is that there are a lot of doctors' offices within the hospital itself. And the system previously, they had one large data center where all the hospitals were just connected directly to that.
Right.
What they're starting to do now is put caches in each of the smaller, especially the smaller hospitals, and the night before, they will push all of the X-rays, files, everything down to that local office so they don't have to reach back to the main data center, one, saving them bandwidth costs during the day, but also having the data there locally accessible so if there is some type of outage, that customers aren't impacted by it.
Okay, yeah, so I think that healthcare is actually a big use case, and I know that anybody who went to the Edge talk this morning by Steve and Megan, I think healthcare was one of the use cases that they talked about as well. I think it's really interesting pre-positioning. So the two types of caching, right? On-demand caching and then pre-position caching. Pre-position caching is really interesting, especially for medical imaging. Yeah, that makes sense. Other use cases? Yeah.
Hi. So actually, my company provides like this concept of edge computing and stuff like that. We actually call it like our edge network or edge sites. Mm-hmm. But actually, so I'm seeing it gets confusing. Like, is it the cloud or is it the edge? Right. Like, which should you pick? At Packet, that's actually the same thing. So for example, you were saying like we definitely, the edge is considered somewhere close to wherever your workload is. So for example, like in the healthcare business, like first, privacy, but also for like, this is like real life, like, life-changing things that need to happen. or IoT, like like all these like autonomous cars are gonna come out, stuff like that. They need computing power, like or processing all the data like that they collect together like much closer. But in our case, actually, we're trying to build an edge network for computing, for networking, for processing, or for just locally, because you want to be local to a certain site. We're building that as we're considering that the cloud. So I'm not sure what, everybody has its own definition of what the cloud is. Is the cloud Amazon? Is the cloud just, these big, the top 3 providers? Or in our case, we automate these data centers or racks. It doesn't have to be a full-blown data center. We automate like if it's in a hospital, we'll put our automation software, make it very cloud-like. So your location, when you deploy your region, is that building or that city and stuff like that. So that's our use case
I agree with that. That makes sense. So do you have so does Packet have particular types of customers or use cases that are really popular on that edge footprint?
Yep, that's exactly it. Yeah. So our customers actually help us expand. So we launched our edge sites to get closer. We don't have a large configurations on there, but we actually allow customers to expand on that. And in today's world, they actually have. So one of our popular sites is like Hong Kong. They, some customers want better networking and latency and routing. They also leverage, because one of the reasons, like you're saying, being closer to ISP, they go through our network, right, closer to the edge. But then we leverage on our network. We built some backbone that actually makes it even better to go to like your real cloud provider via us or Amazon or wherever.
Yeah, so I guess let me rephrase. Is there a particular workload that they're running on there that makes it better?
Yeah, and actually, honestly, it's like video processing.
Oh, okay.
Yeah.
Got it. Cool. Yeah, go ahead.
And to add to Tony's thought regarding autonomous cars and that they will drive the world, basically, they're going to need lots of compute.
Sure.
And that depends. You can do that compute machine learning and create the models somewhere in the central data center, or you can do that on the edge. And can you imagine how many GPUs are crypto mining right now in somebody's apartments, houses, as working just as radiators, basically, without adding much value to it? And in a year, they're going to be, all those rigs are going to be unprofitable. But GPU power and the calculation and compute power is still very, very large of those rigs.
So do you view edge computing as a way for somebody who has a rig like that to kind of hook it up to a
think so.
mesh
that could be,
or network of them?
That could be a way to reuse and recycle basically those GPUs that are just running for nothing mostly.
Yeah. I think that's actually really, I don't know if we want to spend a ton of time on it, but the interesting use case of, we talk about edge computing a lot within the context of a single administrative domain, but we know the internet is kind of made up of multiple administrative domains that are connected to each other through BGP and other protocols. Do we see the same thing happening for workloads, I guess? And I know that, workload migration was like a common theme that kind of petered out a little bit with cloud. Do we see that reigniting itself now that we have containers and a way to kind of define, hey, this workload can go here, here, and here, and I'll pay this amount for it, and it could go on to your edge or to my edge, and we'll monetize it. Is that in anybody's brain? Yeah? Okay. Yeah, who has the mic? No. Oh, were you going to say something, Tobias?
No, I was
okay.
Going to give it a use case.
Go ahead, and we'll get back to you.
Thank you. I work for VMware, and speaking a little even broader, speaking for ONAP, Open Networking Automation Platform, where actually, interestingly, it's from service providers. Several CNCF vendor members are part of it, ONAP, including Cisco.
Yes.
So really when you started looking at this problem, ONAP was so far focused on network services, but recently what we said was the opportunity is much bigger. We need to bring in edge computing into play. And as in the journey, what we realized was we need to take a broader look at that, the whole picture, right? I mean, essentially start with an application perspective. What are the requirements, right? We identified several application categories. Some of them have a hard real-time requirement.
Sure.
Example. For example, if you're doing something like a 5G network function, there are certain control functions as load balancing, which really need a real-time response time. And I'm talking like 20 milliseconds order, right? And they have to be on the edge. There is no other way, right? But also, if you step into the next category, broader category, we see that applications such as video surveillance, right,
Yep.
are a hot candidate like you talked about. But it is not that it is an absolute, when it comes to the latency requirement, they're 500 millisecond and above, so it's not a hard real-time edge constraint.
Right.
But it almost comes to more opportunistic edge deployment. But if under certain constraints, essentially you do really a TCO math. I mean, basically an objective optimization on TCO, and you figure out that edge could be the right location, or it could be somewhere else in the public cloud. Maybe even an Amazon EC2 with the right partnership could be the right location for it.
Yeah, so I guess let's draw a distinction, I guess. I think there are network functions that must be at the edge because that's kind of where they're today, and we're virtualizing them and putting them onto general purpose compute. And then there are functions like video surveillance where it's beneficial if it's at the edge, but the network's still going to work if it's not at the edge. So I think that's what you were saying earlier about opportunistic.
And also just wanted to add, even the network functions, interesting if you break down the data plane functions need to be critical in the edge, but even control plane can be somewhere else.
Okay,
right?
fair.
So it's just such a broad definition. That's when we said, when you look at the application landscape, it's better to call it more distributed cloud computing.
Right.
So with that, the message gets better, and also sort of starting top down what you're looking at from architecture, right?
Got it. Okay, good. Other, yes, please.
Wireless distributed cloud computing. When I run into a cloud, I don't think about where my workload is running. But if I need to run a baseband control unit, it needs to be at a specific place.
Yeah.
So it's not really just distributed cloud computing. There's a little more to it as far as location positioning.
So it's a combination in the sense some have hard constraints and some have soft constraints. It's all about your orchestration to decide, based on those various constraints, to place workloads. That's what it is.
Sure. Okay. Yeah. Let's get back to use cases. So who else has an interesting use case? Yeah. Go ahead. Okay.
I think I can just generalize what I said before, is that the reason why we're doing the edge computing is that, or my definition is kind of like the edge is where the data is produced, and if you can work on the data where it's produced, you reduce a lot of requirements on the network and everything.
Right.
And what we're doing is basically what, like, we're extending the intelligence of pre-existing machines or factory lines, and then when you are monitoring a factory line, you can have thousands of data points per second, but they are not really interested in case or unless something is deviating from whatever requirements you set on them. So
got it.
So the edge is always monitoring, always computing at a high speed. And then whenever you get a deviation, you send that to the cloud and to whoever is interested.
Got it. Okay. Yeah, that's a good use case, manufacturing. Any other use cases we haven't talked about yet? Yeah, go ahead.
Yeah, so related to this one, it's we work with cloud robotics. So they're trying to automate, to connect robots to the cloud. And of course, they have scenarios in which they have some local computation that would not happen on the robots, but you would still want to happen on premises.
Locally, yeah.
So then you have two deployments of Kubernetes clusters, for instance, one local and one remote, and then you can do adaptive placement depending on what you are running in the warehouse, for instance, at the moment.
Yep, that makes sense. Okay, way bent in the back there. And let's make this the last use case, I guess, since we only have a few more minutes left. Yeah.
Yeah. So the one I consider is pretty much using for distribution of video. Yeah, not necessarily for caches, but let's say that we want to have IPTV enabled, to clusters of users. We could have, let's say, those edge computing devices be the multicast endpoint, and then having unicast until the very the very edge of the actual customer.
Right.
So you do unicast, from the customer to that gateway, and then multicast, from the video provider to that box.
Right.
So that is definitely something that can help on the bandwidth, utilization.
Okay. Yeah, a CDN type use case with multicast. That makes sense. Okay. So if you have additional use cases we didn't talk about, I mean, there's a comment section on the forum, so feel free to throw them in there, and I'll try to keep track of those. These are all really good. Just going forward with, we'll skip the fantasy use cases because they're not necessarily real today. But in terms of a Strawman architecture, so the way that I think about it is in each of these edge sites, I think of each one of them as a micro data center, and I think of each one as a standalone Kubernetes cluster. I've seen other architectures where somebody wants to run Kubernetes, master centrally and then treat all the edges as workers. So is there, I guess, consensus that each of these edge sites should be its own cluster, or do we see some kind of other division of responsibilities that makes sense? On each site. Okay, that makes sense. Right. Right. Yeah, so I guess is Kubernetes deficient in terms of its multi-tenancy today, and do we expect that to change in the future, or should we just use multiple clusters? That's probably the easiest thing to do. Maybe, at least today, I think using multiple clusters is the sensible approach per edge site. Okay, that could make sense. Sure.
One thought that I think it all depends on the size of the edge site and type of workloads you're trying to deploy there.
Right.
So one possibility could be, each edge site could have just a single rack, and it's not that you want to have one Kubernetes cluster per rack.
Right.
And you could actually say that, hey, there are 5 sites which are proximal and metro distance, and then they could be controlled by the same Kubernetes cluster. It's totally possible.
It's possible. I guess I would argue that that's probably not a great idea just because of the chance for partitioning and keeping, if a worker gets separated from the master, it can only survive for so long without that connection.
But it also depends on the connectivity, I would say. So we should not
Sure.
preclude that option. That's what I'm saying. I'm
Okay.
not saying that's not always the option, but don't preclude it.
Yep. Okay. So these are some issues that I just kind of threw on a slide. So so today we can work with Kubernetes pretty easily in terms of deploying the cluster and deploying applications on that cluster. But in terms of how do you manage that when you have thousands of clusters is the question that I really want to get at. So does anybody have any techniques that they're using today? I know there's a lot of multi-cluster registry is here now, and we started using that as one of our POCs. But are people planning to make use of that? What are you planning to layer on top of registry? Is there anything else or any techniques that people are actually deploying today to solve some of these use cases? Or are we really early? It might be that we're early. Okay. Maybe, we're just thinking about it. So that's fine. So what about multi-cluster load balancing? So there's multi-cluster ingress, right, that works with the Google load balancer, and that's kind of a global load balancer. But when we're managing things on a mobile operators network, sending something back to the Google load balancer and then somehow getting it back to your edge site might make sense. So is there room for a global load balancer that's not in the public cloud, but rather it's on-prem? It's a privately hosted global load balancer. Yeah.
So one of the things that we use, and we're trying to, so we also have that. I was hoping somebody could pitch in on the multi-cluster registry. So we plan to use that and hopefully build out on that, because we're gonna, for each site, we actually we're gonna be putting one cluster per site, because that makes more sense.
Yep.
And like you said, we don't want to have that issue of having the master lose, because
partial failure.
We don't have one main site. That's our or two.
Got it.
But for the load balancing, we're going to be leveraging what we do internally for locally, and then if we can, we try and push it up to network. But we leverage BGP, BGP on the server. Yeah.
Yep. Got it. How are people thinking about doing proximity routing, getting a request to its closest possible edge site? Yeah.
So also first, the cluster and application deployment that's why I'm here.
Okay.
So we have built our own now, and we want to take advantage of whatever Kubernetes has. But regarding the load balancing, is that we're using, I think it's similar to the demo you had before, that you have a global DNS definition, and then whatever node that you're connecting to or whatever cluster you're connecting to, you will get sent to the closest node that is running the workload that you're looking for.
Right. Yeah, so just to rehash demo that my group did earlier today, essentially we wrote a core DNS plugin, and we rely on Anycast and BGP to kind of get us to the closest instance of that IP address, which should be running at your closest edge cluster, and then relying on smarts there to figure out, okay, is that service here or is it somewhere else?
And what is nice about that for the user point of view is that whenever you're in the factory, you're connecting directly to your device but then if you on your mobile phone and then you walk out of the factory, you will still see the same. There would be no change from the user's perspective, but it would just connect to a different cloud or a different cluster.
Yeah, hopefully, yeah, go ahead.
I think it depends on your type of application, because obviously you're talking about using DNS to route people. And
I am, yeah.
If, like some applications, for example, you might want to target the application to a specific person. So you look at Netflix, for example, they're not going to send someone on Verizon to their Comcast person. So some applications, it might be that you need to talk to some sort of central registry, which then says you need to go to this exact POP.
Right.
And obviously that could be done on the application layer, but like what you did on the core DNS, you could extend that a bit. So it could be that Anycast isn't perfect, but it could be that Anycast gets you to the nearest DNS server, which you say is pretty good. And then you've got some sort of plugin on your core DNS, which then takes all the information, the source IP, the load on the network, I don't know, what clusters are healthy or not healthy, and then returns some sort of sensible thing. And that seems like to me, seems like it's fairly viable to do.
Okay, yeah, I'd like that. Let's see. So any other comments on the load balance? Yes, go ahead. We do have 5 minutes left. Just
okay. So load balancing means that you just direct to a compute cluster or some sort. Now there's an alternative to that, and that is just to allocate more network resources so that you get more access to wherever the compute resources are. So those two are actual substitutes, and if you can manipulate one, you can and the other, you will find an optimum. But if you only use one of them, then you're probably not going to find what the totality of your compute system actually has as an optimum. So you probably need to look at both of them.
So make sure I understand that. So you're saying there's kind of a trade-off there between load balancing versus just allocating more resources?
Yes, for that particular connection, right?
Yeah, I suppose that makes sense. I guess you still need to figure out how to get to the closest cluster.
The assumption is that that I think is wrong here is that you have free infinite bandwidth, which is not the case, and it's certainly not the case in the edge.
Yeah,
and doing allocations to mitigate that.
Right, so I guess that brings us to the next bullet, which is kind of resource scarcity and auto-scaling, which is like, can you scale up and down the application, and can you deal with resource scarcity? So one thing that's really different between the edge versus the public cloud, I kind of think of the public cloud, not everybody thinks of it this way, but as like a bottomless pit of resources versus the edge, which is very much a finite set of resources. So we have a really primitive way to set priority for workloads today, right? You can say that this is a system pod or whatever, and this is a regular pod. What I think we need going forward is probably more of a priority for what's running at the edge. So you might say that, oh, we need the network functions to run there all the time with high priority, but the video surveillance thing, maybe that's okay if that gets evicted from the edge of the network. Yeah.
The difference between cloud and edge is that often the case that you're paying for usage in the cloud. So if you do more, you're paying more. But at the edge, it's like if you have spare capacity for doing computing, and then it's not free, but it's like use whatever is available instead of pushing it to
if
the
you
cloud.
own that edge footprint, like in the factory, then that's true.
Or is it like a constant cost in the edge?
Right. Yeah, that makes sense. And then I guess if you think about what we were talking about earlier, like could we connect all these edges together into one big public edge that everybody can have access to, then there's a question of, well, there's resource scarcity. How do you decide who wins? Like if I'm going to pay $1 and they're going to pay $1, is there like an auctioning way to auction off these edge resources that are so scarce? Yeah.
Yes, that is exactly the point, meaning that you don't only have resource scarcity from the point of view of computing, but you also have network resource scarcity. So as we have networking, you could have some policies that enforce things like network neutrality.
Right.
We are working on something that also allows you to apply those policies to compute resources, because you can say the first one that asks for resources gets them for a given price, but then the resources are all allocated.
Right.
And no one else can get those resources. So as we were saying this morning, you have a limit to the access of resources, which is actually something related more to economy theory, let's say.
Yes, so it's like an economy.
It's exactly, this is the point.
Yes.
So, and there could be applied different mechanisms. Could be auctions, could be other pricing. So
Right. Yeah, a little bit. It's a type of market, sure. Yeah. Could be also, yes. Right.
They're generally doing it for a purpose. They will leverage other things potentially, but they'll be trusted tenants in some way as well. I think we're moving into
That's a good point. So is it always going to be our own workloads that we trust, or would it be, first party and second party, or would there ever be a place in time where we adopt third party? And maybe I think you're right. The third party thing is kind of a magical unicorn. That's probably years out in the future. The second party use case is probably more real, but then you probably know how many resources that's going to require. It's not like you need to balance. Yeah. True. Right. Right. Yeah. Functions at the edge. Yeah.
So it depends on who is the owner of the infrastructure, and how is difficult to install new edge nodes. Because, for example, if the infrastructure is a public infrastructure that can be used, for example, for self-driving cars. I am a manufacturer of self-driving cars, but I don't want to deploy an edge computing infrastructure on a whole country. I will use the public infrastructure.
Okay, folks. That's a good question. So yeah, so we're at time actually, and I personally have to run, I'm sorry. But feel free to continue talking. We probably have to get kicked out of the room, but if you can, sign up for the interest list. I'll try to get the people on there together, either virtually or physically, and then we can take this forward. And if you want to contact me directly, that's my personal email. Feel free to send me spam or whatever you want.